Welcome to Snoozy Facts. Tonight, we journey beyond the world we know, into the silent, endless sea of stars above us. As you close your eyes, imagine yourself floating in the quiet of space. There is no sound, no wind, no rush of life, only peace. Every twinkling light you see in the night sky is a sun, shining across the vastness of time and distance. Some of that light began its journey long before human life ever existed, and now it reaches you, gently, quietly as you rest. The universe is old, more than 13 billion years, yet it continues to move, to grow, and to create. In this calm voyage, we'll explore how it all began, how the stars were born, how galaxies formed, and how, in the endless dance of matter and energy, we came to exist. You don't need to stay awake. Just listen and let the universe tell its story. Take a deep breath. Feel the weight of the day drift away. And as your body relaxes, your mind can wander among the stars. This is your time to rest, to wonder, and to dream. Welcome to the wonders of the universe.
In the beginning, there was nothing. No sound, no light, no matter. Only stillness. And then a moment of creation. Around 13.8 billion years ago, the universe as we know it began. Scientists call it the Big Bang, though it wasn't truly a bang at all. It was an expansion, a sudden silent unfolding of everything that would ever exist. In less than a fraction of a second, space itself began to stretch faster than light. Energy condensed into particles, and those particles formed the first building blocks of matter. Protons, neutrons, electrons. Tiny specks of energy dancing in the newborn universe, still far too hot, far too bright for anything like stars or planets to exist. The universe was pure fire, a dense radiant ocean of light and heat, billions of degrees in temperature. And yet, even in this chaos, there was order beginning to form. Gravity, the invisible hand that binds all things, began to take hold. It pulled the tiniest specks of matter together, drawing them into small clusters, like dust gathering into clouds. As the universe expanded, it also cooled, slowly, gently. After about 380,000 years, something miraculous happened. The first atoms formed, mostly hydrogen, the simplest element in existence. For the first time, light could move freely through space. The universe became transparent. The glow from that moment still exists today, a faint whisper of radiation known as the cosmic microwave background. If you could listen to the static of the universe itself, you'd hear that ancient echo, the afterglow of creation. Over millions of years, the hydrogen gas began to gather under gravity's pull. Slowly, enormous clouds formed, vast regions of darkness where matter thickened and began to collapse inward. At the center of these clouds, the pressure grew, and the temperature rose, until finally, deep within the heart of the darkness, the first stars were born. Their light pierced the endless night for the first time. The universe had found its spark. Each new star was a tiny sun, fusing hydrogen into helium, releasing energy, light, and warmth into the cosmos. These stars gathered into families, great collections bound by gravity, and those families became galaxies. The darkness of space slowly filled with billions of shining points spreading out into the endless sea. The universe was alive. And though it was still young, just a few 100 million years old, it had already written the first chapter of its eternal story. When you look up at the night sky, you are seeing that story continue. Each star is a survivor of time, a reminder that from silence and chaos, beauty can emerge. And now, as we drift deeper into the cosmos, we begin to explore how those stars live and how they die.
As we drift deeper into the cosmos, we find ourselves surrounded by the silent brilliance of the stars. They shimmer against the endless canvas of space, each one a sun, distant yet alive, burning for millions, sometimes billions of years. Stars are not eternal. Like all things in the universe, they are born, they live, and they die. Their story begins in vast clouds of gas and dust, the nebulae. Within these immense clouds, gravity begins its patient work, drawing matter together until it collapses inwards. As pressure builds, the temperature rises, and a spark ignites. Nuclear fusion begins, hydrogen atoms merging into helium, releasing a flood of light and energy. A star is born. In its youth, a star shines steadily. It lives in a delicate balance, the outward push of energy from fusion countered by the inward pull of gravity. Our own sun rests in this stable phase known as the main sequence, a cosmic adulthood that can last billions of years. But even the brightest flame must one day fade. When a star exhausts its hydrogen fuel, it begins to change. For smaller stars like our sun, the core contracts while the outer layers expand, turning the star into a red giant. Eventually, these outer layers drift away into space, forming a soft glowing shell called a planetary nebula. What remains at the heart is a dense, white-hot ember, a white dwarf, slowly cooling over eternity. For massive stars, the end is far more dramatic. When they burn through their fuel, gravity wins its final battle. The core collapses and the star explodes in a breathtaking supernova, one of the most powerful events in the universe. In those few seconds, a supernova can outshine entire galaxies. What's left behind can become a neutron star, an object so dense that a teaspoon of its matter would weigh billions of tons. Or, if the star was even larger, the collapse continues until nothing, not even light, can escape. A black hole is born. Yet from death comes creation. The dust and gas expelled by dying stars drift through space, mixing with others, becoming the building blocks of new stars, new worlds, and eventually, perhaps, new life. The universe, it seems, never wastes a single atom. Even as stars die, there remains whisper the promise of rebirth, a cosmic circle without end. Far beyond the scattered glow of individual stars lie immense gatherings, sprawling cities of light that drift through the darkness. These are galaxies, the grand islands of the universe. Each one contains billions, even trillions of stars, along with swirling clouds of gas, dust,
and mysterious dark matter. From a distance, galaxies look like faint smudges of light against the blackness of space. But up close, they are marvels of structure and motion. Some, like the spiral galaxies, unfurl graceful arms that twist outward from a bright core, immense pinwheels turning ever so slowly. Others are elliptical, vast spheres or ovals of ancient stars, glowing softly like cosmic embers. And then there are irregular galaxies, wild and chaotic, shaped by gravitational encounters and cosmic collisions. Our home, the Milky Way, is one such spiral galaxy, a glittering disk of about 100 billion stars. If you've ever looked up on a clear, dark night and seen a faint milky band stretching across the sky, you've glimpsed the very edge of our galactic home. At its heart lies something extraordinary, a supermassive black hole, millions of times the mass of our sun, quietly influencing the dance of stars around it. Galaxies are not solitary wanderers. They travel in groups and clusters bound together by gravity. Sometimes these galactic giants meet, their stars weaving through one another in slow-motion collisions that can last hundreds of millions of years. Despite the violence of their meeting, very few stars ever collide directly. Instead, their mutual gravity reshapes them, blending their forms into something new, a galactic rebirth. The light from distant galaxies takes billions of years to reach us. When we gaze at them through telescopes, we are looking back in time, seeing them as they were long before Earth even existed. Some of that light began its journey before our sun was born. Each photon is a message from the past, a gentle reminder of how vast, how patient the universe truly is. And though galaxies seem distant, silent, and unchanging, they are very much alive, spinning, colliding, and creating new stars in an endless cosmic rhythm. Every point of light you see in the night sky is part of this grand story, a single note in the symphony of the universe. In the silent depths of space, there exist objects so strange, so powerful, that they defy imagination. They are the black holes, the universe's most mysterious creations. A black hole begins as the remnant of a massive star, one that has burned through all its fuel and can no longer resist the pull of its own gravity. When such a star collapses, it falls inward endlessly, crushing itself into an infinitesimal point known as a singularity, a place where the known laws of physics simply cease to apply. Around this singularity lies the event horizon, an invisible boundary that marks the point of no return. Anything that crosses it, a planet, a star, or even a beam of light, is lost forever, pulled inexorably into the black hole's grasp. But despite their name, black holes are not empty voids. They are engines of immense gravity, curving space and time themselves. Imagine a vast, invisible whirlpool in the fabric of the universe, drawing in everything that drifts too close. And yet, black holes are not merely destroyers. They shape galaxies, influence stars, and may even be key to understanding how the universe itself evolves. At the heart of nearly every large galaxy, including our own Milky Way, lies a supermassive black hole, millions or even billions of times heavier than our sun. These cosmic giants govern the movement of stars around them, keeping entire galaxies in delicate balance. What happens inside a black hole remains one of the greatest mysteries of all. Some scientists believe the singularity might compress matter into a single dimensionless point. Others suggest that black holes could act as gateways, tunnels through space-time known as wormholes, connecting distant corners of the universe or even parallel realities. For now, such ideas remain in the realm of theory and wonder. Even as black holes devour matter, they also emit faint whispers of radiation, a phenomenon known as Hawking radiation, named after the physicist Stephen Hawking. Over unimaginable spans of time, this radiation causes them to fade and eventually vanish, dissolving quietly into the cosmos from which they came. Black holes are both terrifying and beautiful, reminders that the universe still holds secrets beyond our grasp. They embody a paradox, the darkest places in existence, yet surrounded by light drawn irresistibly toward them. As we drift deeper into sleep, imagine them not as monsters, but as keepers of cosmic balance, silent, unseen, and eternal.
If we could step back, far beyond our galaxy, beyond clusters of galaxies, and keep zooming out, the universe would reveal its grandest secret, a hidden architecture known as the cosmic web. At first glance, space might seem empty, but if we could see matter on the largest scales, we'd find that the universe is anything but random. Galaxies are not scattered haphazardly. They gather along vast filaments of gas, dust, and dark matter, stretching across billions of light years. These filaments connect to one another like threads in an invisible net, forming the largest known structure in existence, a web of cosmic proportions. Between the glowing filaments are immense voids, dark regions so vast that entire galaxies could drift through them without ever meeting another. Yet, even within this emptiness, gravity's quiet hand shapes everything. The cosmic web began forming not long after the Big Bang. Tiny fluctuations in the early universe, small ripples in density, became the seeds from which galaxies, clusters, and filaments grew. Over billions of years, matter followed gravity's pull, gathering into long strands while the spaces between them grew ever more empty. It's as though the universe itself is woven from light and shadow. The glowing threads of galaxies mark where matter has gathered, while the dark spaces whisper of what has yet to form. When astronomers simulate this structure on supercomputers, the results are breathtaking, vast, three-dimensional networks that look astonishingly like the neural connections of a brain. It's as if the cosmos itself thinks in some slow, unimaginable way. Every galaxy, every star, every world lies somewhere along these filaments. Our Milky Way is part of one of these strands, residing within a cluster called the Laniakea supercluster, a colossal region spanning over 500 million light-years. Within it, countless galaxies drift together, their fates forever linked by gravity's subtle touch. And though the scale is beyond comprehension, the idea is comforting. From the smallest atoms to the largest galactic threads, everything is connected. The same laws that shape our planet also guide the formation of galaxies and stars. The cosmic web is more than just structure. It's the universe's masterpiece, a silent reminder of order within chaos, beauty within emptiness. As we gaze up into the night sky, we're not looking out at something distant. We're looking at the very fabric we belong to. Time. It is the quiet river upon which all things drift. The unseen current guiding the birth, life, and death of everything that exists. In the vastness of the universe, time
Time moves not as we feel it on Earth, but as an almost incomprehensible ocean, slow, deep, and eternal. When the universe was young, time itself was turbulent. Moments after the Big Bang, everything expanded at breathtaking speed. Matter, energy, and even time raced outward, stretching the very fabric of reality. But as the universe cooled, the chaos gave way to order. Atoms formed. Light traveled freely. The first stars began to shine, tiny sparks in the great cosmic night. From those first moments, the story of time became the story of change. Galaxies grew, stars were born and died. New worlds emerged from the ashes of the old. Billions of years passed, silently, patiently. To the universe, 1,000,000 years is but a heartbeat. Time is not absolute. Einstein taught us that time bends and stretches with gravity. Near a massive object, like a star or a black hole, time itself slows down. What feels like minutes to one observer might be centuries to another. In the cosmos, time is as flexible as space itself. If we could fast forward through billions of years, we would see galaxies drift apart as the universe continues to expand. Stars would grow old, burn out, and fade, leaving behind only white dwarfs, neutron stars, and black holes, quiet reminders of what once was. And one day, far in the unimaginable future, even those lights will go out. The universe will become darker, colder, and quieter. This era is known as the heat death, a time when all stars have faded, all energy is evenly spread, and nothing new can form. But perhaps, even then, the story of time will not truly end. Some theories suggest that the universe could one day collapse and begin again, a new Big Bang, a new creation. Others imagine that beyond our perception, countless other universes are already forming, each with its own timeline, its own beginning and end. Time, it seems, is not a straight path, but a cycle, an endless dance of creation, transformation, and renewal. And as we rest tonight, feeling time slow and fade into sleep, remember this: every heartbeat, every breath, every fleeting thought is a tiny echo of that vast cosmic rhythm, the same rhythm that moves galaxies, forms stars, and shapes eternity.
For as long as humanity has gazed at the stars, we have wondered a simple, haunting question: are we alone? The universe is vast, far beyond imagination. There are more stars in the cosmos than grains of sand on all the beaches of Earth. And around many of those stars, planets orbit quietly, worlds bathed in starlight, each with its own story, its own secrets. In recent decades, astronomers have discovered thousands of exoplanets, planets that lie outside our solar system. Some are giant and stormy, others frozen and desolate. But among them are worlds that seem strangely familiar, rocky planets with the right size, the right distance from their star, perhaps even the right conditions for life. We call this region the habitable zone, the sweet spot where temperatures might allow liquid water to exist. And where there is water, there could be life. Life on Earth has proven to be astonishingly adaptable. It thrives in the deepest oceans, in boiling volcanic springs, beneath ice sheets, and even in radioactive waste. If life can flourish in such extreme places here, could it not also exist elsewhere, beneath the icy crust of a moon like Europa, or in the hazy atmosphere of a planet like Kepler 452b?
Perhaps on a distant world, there are oceans that shimmer under alien suns. Perhaps winds move across purple skies, carrying the scent of a world we will never see. Or perhaps life exists in forms we cannot yet imagine, built from elements beyond carbon, thriving in environments we would call impossible. Even within our own solar system, the search continues. Mars once had rivers and lakes. Traces of that ancient water still mark its surface. Moons like Enceladus and Titan may hide oceans beneath their icy shells. Dark, quiet seas where microbial life could dwell unseen. For now, we have found no clear sign of another civilization. The stars remain silent, their signals faint and distant. But silence does not mean emptiness. It may be that intelligent life is rare, or that it is everywhere, simply too far for us to hear. The universe is young on cosmic scales, and we have only just begun to listen. In the end, the search for life beyond Earth is also a reflection of ourselves. It reminds us that we are part of something vast, a living universe still revealing its mysteries. And even if we are alone for now, the wonder lies in the possibility that we might not always be.
The story of the universe is still being written. Even now, as we sleep beneath the same stars that have watched over humanity for millennia, the cosmos continues its slow and patient transformation. Galaxies drift farther apart, carried on the silent tide of expansion. Stars are born, live brilliant lives, and fade quietly into darkness. But what lies ahead, in the far distant future, is both mysterious and awe-inspiring. Astronomers believe that the universe is not just expanding, it's accelerating. Driven by an unseen force called dark energy, galaxies are moving away from one another faster and faster. In billions of years, distant galaxies will slip beyond the reach of our telescopes, their lights stretched into invisibility. The night sky will grow emptier, lonelier. Our own galaxy, the Milky Way, will one day meet its neighbor, Andromeda. Over the course of billions of years, they will collide and merge, forming a single, enormous galaxy. The stars themselves will rarely collide, but their patterns will shift and swirl, creating new shapes in the cosmic dark. Eventually, the stars will begin to fade. Fuel will run low, and new stars will no longer form. The universe will enter what scientists call the degenerate era, when only the lights remaining are the faint embers of dying suns, white dwarfs, neutron stars, and black holes. Time will stretch on beyond comprehension. Black holes will slowly evaporate through Hawking radiation, releasing their final whispers of energy into the cold. One by one, they too will vanish. And so, the universe will grow dark, silent and vast, filled only with the faint memory of what once was. This is known as the heat death, the point where all energy is evenly spread and nothing more can happen. It sounds like an ending, but perhaps it's not. Some theories suggest that this quiet, empty universe might one day give rise to another, that quantum fluctuations could spark a new Big Bang, a new beginning. In that sense, even the end might simply be part of a cycle: birth, life, and rebirth on the grandest scale imaginable. The future of the universe is not ours to see, but it reminds us of something profound. Everything changes. Everything transforms. From chaos comes order. From darkness, light. And as you drift into sleep, remember the atoms that make you once belonged to ancient stars. You are part of this endless story. You are the universe, dreaming of itself.
And so, our journey through the cosmos comes to a quiet close. From the birth of the universe to the farthest reaches of time itself, we've traveled together across billions of years, all while you rested beneath the stars. As you drift deeper into sleep, let your mind wander through the vastness of space. Remember, every fact, every mystery, every shimmer of light above you is part of a much greater story. If you enjoyed tonight's voyage through the universe, let the stars know by liking this video. It helps more dreamers and night thinkers discover Snoozy Facts. And if you'd like to join us again to learn, to dream, and to drift, subscribe to the channel and tap the little bell so you'll never miss another journey through wonder. Thank you for spending these quiet moments with Snoozy Facts. Sleep peacefully. And remember, the universe is vast, but so is your imagination. Good night.